Today, let us see some more examples on steady state error. A unity feedback system. Therefore, h of s equal to 1. As g of s equal to 1 upon s multiplied by 1 plus 2s. 1 plus 2s. The unity feedback system has g of s equal to 1 upon s multiplied by 1 plus 2s. The input to the system is described by r of t is given. Input equal to 2 plus 4t plus 6t square. Determine the generalized error coefficients and express the steady state error as function of time. How? T square, up to what we can differentiate? How many times we can differentiate? Twice. T square means first time if you differentiate, what you will get there? 2t. If you again differentiate, you will get 2. That's all. So we cannot differentiate more than twice. That's why up to C2 only we require. Up to C2 only we require. C3 no need. If T cube is there, then we need it. C3. Here we can differentiate up to second time only. That's why up to C2 is required. Now we will find for that f of s is required. F of s equal to 1 upon 1 plus g of s h of s. H of s equal to 1. Therefore, 1 upon 1 plus 1 by s multiplied 1 plus 2s multiplied by 1. H of s equal to 1. Therefore, s multiplied by 1 plus 2s upon s multiplied by 1 plus 2s plus 1. We took LCM and the numerator becomes like this. Therefore, this is f of s. F of s equal to 2s square plus s upon 2s square plus s plus 1. This is f of s. C naught equal to limit s tends to 0 f of s. That is equal to, if you substitute s equal to 0, it becomes 0. C naught equal to 0. C1 equal to limit s tends to 0 d by ds of f of s. That is equal to d by ds of f of s equal to, we have to differentiate once and let limit s tends to 0. If you differentiate once, what you will get? 2s square plus s plus 1 whole square, 2s square plus s plus 1. If you differentiate the numerator, 4s plus 1 minus 2s square plus s. If you differentiate the denominator, 4s plus 1. 4s plus 1. So if you let 4s plus 1 is in both terms. Here 2s square plus s plus 1 minus 2s square plus s. Upon 2s square plus s plus 1 whole square. That is equal to limit s tends to 0. Limit s tends to 0. If you make s tends to 0, this becomes 0. This becomes 0. This is also becomes 0. Therefore, the remaining terms are numerator 1 only. The denominator also 1. Therefore, C1 equal to 1. C2 equal to what? C2 equal to limit s tends to 0 t square by ds square f of s, that is equal to d upon ds of, already we have the first derivative, that is 4s plus 1 upon 2s square plus s plus 1 whole square. Limit s tends to 0. Limit s tends to 0. If you differentiate this once, you will get 2s square plus s plus 1 to the power 4. 2s square plus s plus 1 whole square. 4. If you differentiate the numerator, you will get 4 minus derivative of denominator is 2 2s square plus s plus 1 4s plus 1. You have to write as such the numerator 4s plus 1. Okay. If you let s tends to 0, this becomes 0, this also becomes 0. This also becomes 0. This also becomes 0. This also becomes 0. What you will get here, 4. 4 minus 1 square is 1. 4 minus 2. 2. Okay. Upon 1 power 4, 1. That is equal to 2. C2 equal to 2. Therefore, error series E of t equal to E of t equal to E of t equal to C0 is 0. C1 is 1 multiplied by R dot. What is R? R is 2 plus 4t plus 6t square. Therefore, if you differentiate once, R dot equal to R dot equal to 0 plus 4 plus 12t. So R dot we have to substitute, that is 4 plus 12t divided by 1 factorial. This is minus. C0 we didn't get any minus. Okay. Plus C2 equal to what? 2 plus 2 R double dot. R dot equal to this. Therefore, R double dot equal to what? R double dot equal to, again, this is 0 plus 12. R double dot equal to 12. That's all. By 12 divided by 2 factorial. 2 factorial getting cancelled. Therefore, 12 plus 4, 16. 16. Anyhow, answer is infinite.